Hello and welcome, everyone. My name is Peter Robinson, and today we have Tahir with us, who is going to tell us about decentralized execution sharding, which sounds like a very promising technology to help with scaling. So, before you launch into your talk, why don't you introduce yourself, Tahir?
So, no, thank you very much, Peter. So my name's Tahir Mahmood. Born actually in Nairobi, Kenya, but moved to the UK. So predominantly spent most of my life in the UK and England. And current project is Kernel, and this is how I came across Peter and one of his YouTube videos and thought, wow, this is amazing. Connected with you, and here I am today.
Well, it's great to have you here. And we had a brief chat about the technology, and I thought, it'd be really interesting to hear more, have a really well thought out, explanation of the tech for all of us, and to promulgate the concepts to everyone. So please go ahead.
Lovely. Okay, so I'll go by, I guess, starting by going. It's always good to put some background to a person, so at least you have a context of where my knowledge comes from. Like most people, I mean, we've been coding for a while, but I started in 1979, and literally machine code and assembler is where I started. Went to Manchester Polytechnic, and really, I think the core of my background started. I always say my pivotal point was Loughborough University, this thing called Computer Human Interface Research Center, where in the mid 80s, I literally ended up doing AI, parallel processing, and this thing around a programming language called Occam on transputers, these little machines that you could just connect together, and distributed computing, obviously, systems using C, Fortran, and so forth. It was that really got me on the radar, where I think through Scouts or whatever it may be, as soon as I finished at the university, I got hired at Microsoft, and it was Microsoft UK, but sort of working with Redmond, and became the lead for operating systems and programming languages. And, I always say to people that, part of my sins is that I helped bring out Windows and then OS2 and NT. So a very, very long time in the game. I left Microsoft, went on to the US, to build my own business, actually, where I started creating gateways, email gateways, because that was my last sort of assignment whilst I was at Microsoft. And then from there, I invented this technology called push email, and the idea that you can actually take a device with your thumbs with a keyboard and actually use it to receive email and respond to email, open up your attachments in terms of what was in those days Office, Word, Excel. And that became the root patent for the BlackBerry. And I am the actual recognized owner of the root patent for that. I spent a lot of my time actually working in diverse systems, and this is we're talking from mainframes. For those people who ever have IBM 3090s and minis, AS400s, and sort of all that. So I cover everything from mobile to distributed to cloud to mainframes, and that's probably quite a broad width, but that's always enabled me to work on very large global scale systems, because banks, as you can imagine, tend to run on mainframes, because mission critical stuff where you've got high reliability is something that is very, very hard to get in distributed systems. So everybody starts with this idea of distributed systems, but ultimately in some way ends back into a centralized mainframe, which still has value for money. I also did a stint with Apple, where in 2004 to 2008, I was sort of pivotal in working out what should be Apple retail and what should an Apple retail store look like. And I actually did finance and build the first one in Warrington in the UK, just northwest or north, is it? Yeah, northwest of England. So there's a lot of that I've done with Apple in Cupertino. Since 2016, 2022, really, up till now, it's a very fractional role, CTO, chief architect roles. But I've just highlighted some prominent pieces of work that I did in terms of working with the Microsoft Orleans team in terms of the Halo engine and scaling it for what was FIFA to 1 million concurrent users with a game that was being implemented. So we needed to re-architect some of the design of that sort of engine and that product. A lot of work that I've done around blockchain and Web3, which has brought me to my journey where we are today, was I was helping sort of manage projects of building custodians, DAOs, but I did a project, a stint with the United Nations, where they wanted to know how they could track and monitor containers on ships, because quite interestingly, how containers carrying waste from one country to another, the containers seem to fall off the ships. That's quite strange, and disappear into the water. So when you arrive on the other side, there's a few less containers to dispose of. So we wanted to track that with IoT devices, and using relevant telecommunications and so forth. So that ended up as a paper I wrote to do with how blockchain could be used to do that, as part of things. And as you can imagine, it turned into something quite big. So that's just a brief background on that. What I'll do is, I want to mention something here, which I think is always worthwhile, because I started my career very early days at Microsoft in 1989. Working with Nathan, who became the CTO at Microsoft. He created this paper to do with creating a Microsoft research plan, and presented it in 1991. And for me, one of my heroes in distributed computing was this chap called Rick Rashid, or Dr. Rick Rashid, and he sort of managed the research lab side of things for Microsoft. But I sort of predated Rick, but sort of postdated Nathan, who I think was there from about 86. So these guys were very prominent in my career in terms of what they were doing and what was being done, because they were heavyweights in building operating systems and so forth. So I just thought it was worth mentioning that these people are really inspirational to me. Okay, just moving on where I am today and what the purpose of the talk. I met my co-founder Asim back in 2 years ago, I guess in November 2022. We decided to go down this idea of this, what I'm going to explain, how execution sharding came about, raised a pre-seed. We opened an office, and it's here that my colleague Ice is actually on this call, so he can also jump in if he'd like to and sees there's value to add in, especially in the questions and answers later on. And obviously we're now at a private testnet. So that's where we are. So now let's start with what this vision of execution sharding and everything that it is. Obviously, you can imagine, having worked with the United Nations and other parties around the world, which I tend to do, this idea of the next generation internet, which is called the Horizon program now, as part of Europe, it is very prominent in the sense of how we feel we should be using the internet and the technology that's out there today. And you can see, it's got highlighted words like enable human potential, trustworthy, an open environment, sustainable open environment, and again, a lot to do with sustainability. But all this tells me is more and more of how we've got such proliferation of devices. I mean, I think I read a report somewhere where we're going to have so many billions of IoT devices, so many billions of mobile phones, to the point that with Tesla and their robots, again, these are just at the edge devices, if you can call them that, fog devices, all the other clever phrases that are there. But the level of compute and distributed compute that we're going to need means there's so much more power. But at the moment, how do we take advantage of it? So that's really where this whole idea of execution in terms of distributed execution comes about. So this is obviously the most fundamental thing, which is almost every application in any formal way is made up of many processes. Now, the idea is that, do you run all those processes on one core, on one processor, which we've been used to, certainly from my early days in the 80s. But now we have this idea that you have a lot of capability in multiple processors, so you can partition an application into many areas and have them run, especially with parallelization, to be able to get the performance, the non-functional requirements that we're all after, the redundancy, the reliability, all of these things. And that's really the core of where the idea of execution sharding on blockchain came about. And what I'm going to do is cover that. So there's a recent paper that my co-founder Asim sort of spotted, and we sort of use this as a way of presenting what execution sharding is. And Vitalik posted this thing about glue and co-processors, and the idea being is that if we look at current blockchains, no matter what level they have in their trilemma of security and scalability and everything else that goes with it, smart contracts obviously have limitations. And just prior to this call, you brought up the words to do with code is law, and obviously that means that that environment, that virtual machine, that's running the smart contract, has to be limited in what it does and what it's able to achieve. The fact that you are pulling bytecode off at the moment of it when you want to execute it, and that bytecode cannot be changed, and the machine is constrained by what it can do, means again the smart contracts become very limited in the logic that you can have inside them, and finally do that state change as a way of recording whatever they need. So Vitalik's paper, this thing to do with glue and coprocessors, is all about the fact that you can get this extra capability of processing, but his talk was very much about doing it within the EVM itself. And for me, based on I put my hands up 40 years in this industry. Maybe this is the one time I would say I probably don't agree that it can be done in the EVM. If we look at the technology itself, how do you activate or spin up a smart contract? You send a transaction, arrives in a node, gets propagated in the mempool, has to be mined, and it's only then that the EVM can pick up that call to that function and sort of say, okay, I'm going to execute this, and then it executes across all the nodes. And that all of that is wasted resource, and it means there's a finite limitation of how much you can consume. So if you're trying to do something with tens of millions or billions of calls coming into the network, how do you achieve that? And to me, it's just not scalable. I don't think we'll ever get to the point where, with the current way that smart contracts work. So I've seen technologies where people have gone, okay, let's just use this idea of, at least with databases, we all understand sharding, what database sharding is, and I'm not going to go and try to explain that. I think everyone here understands it. So this other idea is how do you break it into smaller components of sharding for execution, which is how can we make it so we still keep the reliability and performance and capabilities of a blockchain, but have it sort of sectioned off, but so we still maintain the ability through whether it's consensus or correctness, that we can still say it's working as it should do, and the results that come back are still tangible and credible. So anyway, Vitalik goes on to talk about this central glue component, as I said, coming out of EVMs. But my view is that it actually has to be done somewhere else. And when I say somewhere else, I've been working predominantly on the technology on the node itself. And the idea behind it is that it achieves another goal. And the other goal being is that we have a lot of different technologies and blockchains, and we have a lot of off-chain, call it Internet Web 2 capabilities that we want to bring into the fold, into a very holistic platform where everybody can sort of go, as a developer, I shouldn't be constrained by just the libraries that I can utilize within my blockchain and the smart contract and the EVM that I have. I see a lot of things about, people with different projects now talking about parallelized EVMs. But I come back to this thing again, which is you can only optimize opcode performance and execution to a certain degree. And yet you're sort of saying, I've built the best thing since sliced bread, come to me. And then you've got, thousands of other technologies and blockchains being brought about, including Web 2 and Internet. And I feel all of that, is capability that should be done and brought together in a very holistic way. So the idea of execution sharding is again, we're talking about saying we have all this capability and we should be able to execute whatever we want, wherever we want. And, those people who've worked in, moved from monolith to sort of the cloud environment, we've gone from a monolith to microservices. We've gone from, that into containers and orchestration. We've gone into, data planes and control planes, into service mesh. I can explain all of these technologies. For my sins, again, I've been around so long, I've seen all of this develop. And, Sam Newman, who's came from a very prominent consultancy, has written many books on everything to do with, microservices. I think he's almost maybe considered as a founder of it. And one of his latest books to do with distributed computing, and in one sense, execution is very much about, it's all about resilience and reliability. That is what we're looking for. So I come to the conclusion that the EVM is not the place where we should just be throwing everything, the kitchen sink, at the EVM. It has to be somewhere else so we can utilize all of this capability. So the idea being is that we let people, developers, do what we've always been good at doing. And I say, in a way, if we look at the way culture has worked in software development, at one stage, I remember back in the 80s, I could sit there in front of my computer on my laptop or a desktop in those days, or even working on a mainframe. And, I can even go back to the days. And I remember in the early 80s, I literally did punch cards and went to the town hall and actually put my punch cards down and asked, can you run these and let me know what the output is? And then having to go back. So, I date back to those days. But these days, we're at that point where when we build something, we really want to be able to go, you know what, I want to utilize everything that's around me, all of the libraries, fundamentals of programming. The first thing I ever learned when I opened up an IDE and I started programming, and my IDE was just a normal, like a notebook, not even a proper IDE, was the first thing you do is you import libraries. You want to reuse components. You never build something ever from the ground up. If you did, we'd never build anything. We would ever just be writing device drivers to read the keyboard, never mind anything else, or output something to the screen. So this idea of components is very, very important to me in terms of software development, as we all know. But the culture of going into this idea of having agile scrum teams, all this other stuff that we have, tribes, all the things that we hear around it, is that we can actually build things in units, in containers, and orchestrate them and work with them, spin them up in different environments, have redundancy built in. So going on for that, I'll come to this idea of what execution sharding brought about for me. So the goal was, let's think of a technology where what we can do is, in the world of Web3 and developing dApps, how can I initiate a transaction through a dApp and get it into, and I use the word loosely, a network, right, which means an entry point to an RPC node, an entry point, but no, I can utilize everything, literally holistically everything. So I'm not constrained by the one sort of a blockchain network and the EVM and what it offers. But what if I could get to every single blockchain, every EVM execution environment, and I can orchestrate that just like we're used to orchestrating in microservices. We have this thing called Kubernetes that spins up for containers, or even serverless computing. We can do that very quickly. So the idea was that, how about being able to make it where I can say, as long as I can execute whatever I need anywhere on any chain and off chain, get those results, the same as we call a function. We call a function, we have a signature of a function, we have some parameters for it. We call that function, it returns a result. We take the result and we take that result to the next stage of the logic in our code where we need it. What if you could execute all of that from anywhere, take all of that, all the results that come back from that, and transport them to what is the final smart contract? So the final smart contract is able to say, okay, you know what? I've not been constrained by the limitations of me as an EVM or my libraries of code. And yes, I can, from my smart contract, delegate calls down. Maybe I can call oracles, and oracles again bring their own problems to the party, trust, speed, performance, cost, which is a massive part of it. And this way, you're actually sort of saying, let's not do something on the back end when I need something. Let's do it on the way in, if that's one way of achieving it, and actually get to that final point where the only thing that matters is the state change. Just like we, write to a final database at the end of the day to sort of say, I've placed an order for an airline ticket or whatever it may be, or you want to record it. So we keep the amount of execution on the destination, or what I call a registered smart contract in our ecosystem that we have. to a minimum, but have everything executed, but executed based on, and I use the word optimized environments. So what I'm seeing is that, if you build one blockchain and you say, I have the most super duper best thing ever since sliced bread, and it's got everything it needs, it's parallelized, it's the most secure, whatever, but you're trying to build everything into one place, but you're forgetting there's a lot more technology and a lot more versatility and flexibility and things around the ecosystem. What if you could use all that, whether it be TEE environments, fully homomorphic environments? If you think of EVM chains, simple thing like a random number function is hard, but you have it on other chains. Being able to use that as part of your transaction lifecycle flow, all of that becomes really accessible to you. So what really execution sharding to me is about is how do I build a piece of technology which will allow me to achieve these goals, this vision that I've just laid out, which is, a builder. And I guess somebody's going to say to me later in the questions and answers that in 5 years' time, it'll just be AI who's building it all anyway. And as long as AI knows where, a service discovery and service invocation is somewhere in its brain, it will know how to hook up and tie all this together. And I completely believe in that. I mean, I believe certainly we will reach that stage very soon, even quicker than I thought in the past. Okay, so here what I'm going to show you is this idea of two things that we needed to achieve on working on the node from a technology point of view. And that was, how do we have the node absolutely know that, what it needs to execute can be executed and orchestrated. But number two, how can we make sure that it's an honest node? And how can we make sure that there's not just proofs of the calculations, but there's correctness to it as well? And the idea here came to me through this idea of a certificate authority that we have in the Web 2 world, where, basically with HTTPS, with TLS, all of that, how do we secure a website? How do we secure that? Do we think this is an honest actor? And the idea was, you have a certificate authority that you go to, you trust it, and you say, please, can I have a certificate, blah, 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 and you get a certificate and you install it. So what came up here with was how to have it that you could take let's say an Ethereum Geth node, which is now modified to be able to do the execution of everything I've described on many chains. Ultimately, it's making RPC calls out. And for those people who who know a little bit more about the Geth node, within the Geth node, it's interesting how many other technologies are still built in there. And we know with the Geth node, not only are you doing RPC calls, HTTP, IPC, but there is an actual GraphQL interface. A GraphQL runtime is built into the Geth node. So for me, one of the things with a lot of work I've done with GraphQL was, well, fantastic. You've got this runtime within the Geth node where I can literally take resolvers or build custom resolvers, which allow me to send a query from within the Geth node and be able to say, satisfy this query. And it could mean that the custom resolvers allow me to reach out to any chain, reach out to any Web 2 environment using Open API spec, even reach out to using account abstraction. And I call them adapters rather than resolvers, to all the different areas that we need to span out to. And, again, being a very optimized the way of using, with GraphQL and heterogeneous environments, it's very easy to do that. So I decided to use that capability. So that sort of helped me with the execution sharding aspects of things. But I wanted to make sure that I can have proofs and security and everything else. And this is again, coming back to this idea of a certificate authority, which was, let's build this thing called a token authority, which would act as a controller agent relationship or master slave to a node and keep it honest. But one thing I wanted to achieve was the ethos of Web3, which is having it decentralized. And the goal was that I can create a centralized token authority, which I spun up in my early days of proof of concepts through one of the cloud providers. But I wanted it to be decentralized. But at the same time, I wanted it to be private and secure. And the reason for that is that the handshake and the communication, and how do you make sure you provide some way of authenticating or attesting that the execution that's happened on the node is correct, requires me to use cryptography. And to me, the most scalable way to build what I think in blockchain is, without going into this idea of restaking and everything else, which economic security I don't think is scalable. I think it ostracizes a lot of projects and a lot of people. So I'm very much into using cryptography, which was, how can I store a private key and use it to sign something, which can then be used to prove later on in the smart contract that the execution, what I call the execution plan, actually happened as it was supposed to happen. So this is where, this idea on here, the on-chain authority, came through private networks like Oasis Sapphire and Clique and all of these others that are there. So anyway, moving on. So now the token authority is this thing that is using cryptography and sort of saying, okay, you know what, I'll be the decentralized actor running on a blockchain that is fully decentralized, and it's just another smart contract. But because it's holding a private key, which is going to use to sign to create this signature token, this piece of cryptography, had to settle on a scheme. And obviously, this is where ERC 1271 is the most prominent one. Easy, you sign something, create a token. When that's received within a smart contract in Solidity, it's easy to recover that and be able to sort of say, okay, I can prove authenticity. Another word we use is proof of provenance. Okay, so I've talked about GraphQL. I think I've given a more talk about it, or spoken about it. So those people who know GraphQL will understand the power of it. Very modular approach to it. So now the whole idea of execution sharding is that all this execution that's going to take place across different environments, different ecosystems, has to be obviously secured, and it should be done through cryptography. And one of the things I loved at DevCon that happened in Bangkok just 2 weeks ago was that Justin Drake did this talk about moving from the beam chain, from the beacon chain, sorry, to the beam chain, where moving away from proof of stake, which again is economic and sort of restrictive, to something based on snarks and cryptography. So that scales much better, and that will create much more performance and everything else. And that sat very, very well within the technology that I've been working on, and went, okay, I'm glad somebody else realized that is really the way to go. So anyway, I'll give an example here to everybody. And I think the biggest example and the easiest way to explain it is, people in obviously Web3, most people are aware of the Aave smart contract. And what I tried to do in this diagram is place how an Aave smart contract is broken down into its different components. You have, general logic, price oracles, risk assessment, calculation, interest rates, and everything else running in the EVM. And that's done through Oracle, reaching out through oracles, or the whole code is there. What if you could have a different scenario? And the scenario being is that the EVM only needs to do the component and part that it needs to do, which then means that EVM is, and that node that's running and that network is now doing less and only focusing on what it's supposed to do. And this idea of single responsibility, I think, a lot of us here are hardcore seasoned developers. We all understand, design patterns and the gang of four and all of the factory patterns and all the other stuff that goes on to do with, principles of good engineering. And to me, the idea being is that you should be able to remove all of this that's on the EVM off and onto the node. And the node, and this is the first time I'll use the word, changes from being something that works with data availability and spinning up EVMs into becoming a bit of an operating system. Hence, I come back to the word why the company is called kernel, or the project is called kernel. It's more about being an operating system and saying, I'll help with this and with the orchestration and execution and everything. So here I've moved all the components that we could take off the Aave smart contract onto the node, and saying, now, not only can I execute all of this, because most of this is stateless, so it can be stateful, but predominantly stateless. And now if I want to change the price oracles, I can do that very easily without having to scrap my smart contract on the EVM, delete it, or sort of change a version and have to force it, or whether use upgradable smart contracts and, again, change the way it works. I can do this in a much more simpler way. And from that, You can even go to the point of saying, what I've done is I've broken down my smart contract into smaller components, which I've broken it down into and control. But what if you take all of the capabilities and functions available on every other network, no matter where it may be on or off chain, and I make them accessible also to me so I can reach out to them, execute them in their optimized environments, get the results back, and sort of create a payload which contains pretty much everything that's needed, and have the final payload be the only thing that's delivered to the smart contract on the EVM, where the EVM can say, okay, all the hard work has been offloaded for me, I'll just do the final component. So this is an example really of letting people know how this technology of execution sharding, I believe, should be going forward. And back again, okay, let's start with, so in this architecture diagram, you could call it a C4 diagram, if you're going to put anything to it, was basically just a quick walkthrough of how I see execution sharding being developed, and pretty much this is exposing how we've done it as part of my current project. And the idea is that obviously a DApp user, we know we all have an SDK, whether it's web3.js, ethers.js. In our case, we call it kernel.js, and you obviously sign your transaction using your wallet. But when you make an RPC call from that library into the node, and generally when you make it into the node, is you're actually calling the functions or modules or namespace on the get client based on what it is you obviously want to achieve. And we've exposed our own namespace called kernel. But the GraphQL engine I spoke about earlier is what's the runtime is built into the Geth engine. And as I said, these custom resolvers which we've created, which allow you to make RPC calls to other blockchains or using open API specification into the Web2 world. So if you want to access RESTful API, you literally just create the schema for it and upload it, and Bob's your uncle, it works. The most important part, as I said in this, was the compute engine and the token authority, because to achieve this idea of orchestrated execution, but make sure that it's proofs with correctness, this is where the token authority comes in. And the intention is that what happens is that you execute all of your functions, we call them kernels, whether to be on blockchains, other chains, or on a Web2 environment, get the results back. And that the controller agent relationship between the compute engine and the token authority is where the compute engine provides the results back to the token authority and says to it, here are the results, please can you verify and attest that everything has taken place that is correct and is reliable. And if so, provide me like a certificate authority, a certificate, a signature token, I call it, which is then returned back to the through the node to the SDK. And this is where atomically the idea is that the transaction is then signed, providing the payload with the signature token as a proof of the correctness of everything, and then transmitted back into the node, which ends up in the mempool, and then finally mined and executed by the smart contract, which then says, I've received everything. I've got all the data I need. I've got an attestation, a proof, a signature token cryptographically. So it's done very quickly that I can recover that with ERC-1271. I've got proof of provenance, proof that everything here is correct. Now I can use this data with confidence, and I know I've offloaded all of that proof off the EVM, and I'm not even having to call oracles and rely on what I get from oracles, because the proofs are there that the legitimacy of the data that's come in has got proofs either due to the correctness or with actual proofs like ZK snarks or whatever it may be as part of the payload that could have come back from the different blockchains or Web2 services that are offered. So in essence, what this diagram just basically says is, it says here is one way of building a solution to do with execution sharding, doing this one on the node. That's the most particular part about this, which I think has been very hard for people to grasp. And I know with the way I've gone about this is because, as I said, because of my experience, I've always felt that, you can't do distributed computing and at scale if it's done within, let's say, a Java virtual machine or an EVM at that place, because that can't be the point from which you will reach out to everything. It has to be done somewhere else. And generally, that's done at the operating system level. The operating systems are there to help coordinate and instrument and orchestrate everything. So for me, the goal has been, let's make the blockchain node become the bit that does more than data availability, managing a data store, and just spinning up an EVM or acting with a module to do consensus. This is where a lot of more technology or a lot more capability has to be built. So this is basically the way, coming back to this, my vision of execution sharding, I've gone about it. So, and again, I would love, as part of now this, chance to talk with all of you to get your feedback. And, but, if there was a call to action, I would say to everybody, this technology we've been building, and I have, one of my senior lead developers, Ice, on the call with us on this. And I think my co-founder, Asim, may have even joined. I'm not sure. But, please ask all the questions you need under the world. And I'd love to hear about other people's way of their idea of execution sharding in case I've missed something. Peter, I can't hear you if you're speaking.
Yeah. Not speaking yet. I'm just thinking through what questions I have. So one question I've got is the token authority signed saying the execution was done correctly. Does it just do that on faith, or does it have some way of knowing that the execution was done correctly?
Yeah, good. No, very good question. So, the idea is we have an open framework. So we don't prescribe or have an opinion as to how you do. We create you the skeleton, the framework to do this. So I'll give you some examples. So. And this idea of an onion layer of security is built around this framework. And I'll give you an example. So imagine, for the simple fact of it, at the moment, that on the node, you've gone away and you've called another blockchain smart contract. And in this case, let's say you've gone away and you've called Gitcoin passports to get a Sybil score to do with Sybil attack, whether it's a bot or not. And that score comes back with the number, which is higher than 500 or lower than 500. And you pass that number to the token authority, and the token authority goes, okay, I've got this number 500. I need to decide whether that is greater or less than 500, and what should I do? Because the token authority, again, is something that is a smart contract built and deployed by the same owner who deploys the ultimate, what I call registered smart contract, the relationship is that the token authority is by the same builder as the smart contract, so they trust each other. So the token authority, because it's built by the same person, is the one who has to make a decision as to what it believes is right or wrong. And it can put logic in the smart contract to what to do with this number 500 and make an opinion, which is, I'm good or bad. Now, you might say, well, there's no real proof there that that number 500 actually came from a Gitcoin passport smart contract. And even if the number 500 was manipulated in some way on the node itself, maybe it was 400 and the node maliciously changed it. So these are all the scenarios I can imagine you're thinking in your head are happening. Okay, so the way we secure this is a number of ways. So to start with, and this is this security sort of layer and layer upon layer. So one of the things that is built into this architecture is the node and the token authority can only communicate with each other we're using two things. One is there is a runtime digest, which is calculated in the binary when it's executing the code on the node. And that runtime digest is a whitelisted in the token authority. So let's say we built it a binary and we execute it and we calculate the runtime digest, we provide that, and the person on the token authority can say, if I'm running version 1.1 of the kernel node, I know if it's not been changed in any way, I should get this runtime digest with any communication happening between the node and the token authority. Okay. And, you know, I've had many clever people say, well, I can just hard code it. And I've said, well, if you hard code it into the binary at the time of when it's running in runtime, unless you literally stop it in runtime and then modify it and so forth, which is a very big lift, you cannot just do that. It's not as simple as just hard coding it. Okay, so one way of protecting and saying that this node and the token authority says this is honest, it checks this runtime digest in every piece of communication that happens between the node and the token authority. Okay, another layer is when you spin up a node, you install or set up a private key, get key store and whatever. And interesting enough, the way you have to communicate between the node and a private network like Oasis Sapphire is that everything has to be signed with the private key of the node with using their client SDK before you can call the private network, because you have to protect the data in flight as well as in rest. And so you have to sign it. And what we do is we under token authority, we allow you to have a whitelist which says, as part of the interface we describe, that you can whitelist all the nodes that you trust as a token authority. So any communication has a runtime that you are whitelisting with public keys, again, using cryptography, the nodes you trust. So if as a token authority, the smart contract developer where you've deployed your token authority, you're starting to add these layers by sort of saying, I only trust those nodes. I only trust that runtime digest. You're adding those layers. So by the time you do get that result of 500 back, you can be sure of the fact that the node that's been executed is one you trust. So that's an implicit, I trust because of these sort of numbers. And then it can use its logic and say, the number 500 I got back is that it's not a bot, and I'm okay to attest that it's not a bot. And that logic, again, is something written by the smart contract developer. We have just given you an interface. The logic is up to you. You define that, and then you attest it, you sign it using the private key. So I think that gives you one flavor. If we take it up to another level, the other level is that what ends up happening is that the people who are building the current function smart contracts or off-chain provide proofs, actual ZK proofs or other levels. So now what ends up happening is when the results are returned back through the node and are given to the token authority will have an actual proof of compute or the correctness of what's been provided. And the token authority can say, that is the proof I'm looking for. So I know even if the node had something malicious, as an intermediary, I don't trust it, but I will trust the function because that new function is returning a proof. And I know it's originated from the right place, and the result I can trust.
Yeah, that makes sense. Yeah, I can see how that can work. A little improvement to your architecture, well, I don't know, anyway, take it or leave it, but at the moment you've got a private key in that contract, which, you know, generally is pretty problematic, you know, in that token authority contract. And so a way of having that private key not in that contract, but still having it being having the logic around what you're going to trust, you could have the node calling it and saying, here's a blob of data. And then the contract assesses it and says, yes, I trust that data should be signed. And then you can have a queue of data that should be signed, and then an off-chain party that has the key to sign the data can then read that data and then put the signature on chain. And the public key could be on chain. And so you could even verify the signature if you wanted to. And that would be a way of having the private key not in the contract, because you've essentially have a queue of data in the contract of stuff to be signed. And then you could have this off-chain party that signs it, puts it back on, and then you could have a queue of signed data in the contract. So
I know, I understand what you're saying. So what you're saying is not to hold the private keys in the token authority, which, as I said, is running in a TE environment anyway, with HSMs and everything, so it's quite secure. But what you're saying is to add another layer where that queue of data that needs to be attested or signed is done by another party out off chain. Is that what you're
Yeah,
saying?
and in that way, that contract could be on Ethereum or could be on Polygon. It could be anywhere, and it means that the actual logic for what do you trust is very public because it's a public smart contract.
Oh, okay. Yeah, interesting. No, no, I definitely. Okay, yeah, no, good. I'll take a note of that and see how that plays out, because some of the rules that we have, which we sort of have to maintain, is how do we stay, decentralized? How do we stay trustless, and all these things. So as long as it meets those rules, then we're good with that. So I can see where you're coming from. Okay, yeah, very good. I
Yeah.
like it. Love it.
Yeah. So anyway, look, did anyone else have questions?
Hi, Peter. So I have a question regarding your suggestion earlier. Um, so you're saying that we can have a signer off chain. So how you can make that in a way that it's trustless and decentralized and automated?
Yeah, well, trustless is a challenge because yes, you're now got a central party who could operate it. Um, you could have, so you could have a multi-sig. Here's one for you. You could have a multi-sig where it is, but it's a threshold multi-sig, and you only need one of, say, 20 to sign. So you've got 20 possible signers, and all of them have the opportunity to sign the data. And so they all represent essentially systems that are operating. I mean, that could be another way of doing it. So it's not completely trustless, but you're now you've spread your trust across, say, 20 different entities. It's not the same as something on the blockchain, but then you don't have a trustless system anyway, because you've got this smart contract that you're executing, but it's private, so people can't see the logic. So at the moment, yeah, I think there's a bit of a trust thing. Even I know it's in a TEE, so hence you've got stuff, but
So even if it's right now we're using OSS Sapphire as a POC, and it's actually an TE network, so it's not a single node or a single smart contract that it has multiple nodes running TEs. So it's
yeah,
kind of decentralized.
yeah, yeah. Well, as well, I guess if the code's out there, but I think the big problem is you've got that private key, which I'm sure you've been all grappling with, how to deal with that private key and yet have everything open. Yeah.
Yeah, add to that, Peter. What's interesting is we're currently doing a proof of concept with a new project called Sig Network, team out of NIA, that's their research team, on building a cryptography bridge using our technology and using the sort of signatures, and how you just swap signatures, so it becomes cryptographically. And we should have a proof of concept ready by what's today, Wednesday, Friday, interesting enough. And I'd love to in the future jump on a call and show you what we built, which is a bridge with very few attack vectors, and importantly just very, very low fees and very performant using these technologies. And we came to this, and the reason I'm bringing that up is this idea of these private keys that are held in the TA was, then we decided to take the same MPC network that they use as part of the SIG networks technology and make it as part of the TA. And to go down that route to try to make it work. And that's part of what we're trying to put together with the POC. But again, this idea of using an off-chain or a different signer is this MPC things. So I know we're already working towards that, but it's interesting with what you've come up with, because I like the idea of what you've said is where we make it so the TA is also almost running in public, but then the final signing part is done with another party, so people can even see that the TA and what it's doing, and somehow we got to make it still work with the signing aspect of things and how we make that work. But I definitely think I think yeah, I think people are starting to mention be careful of DAOs. Yeah, DAO's California case last week decided DAO as a general partnership where members. Yeah, it's interesting actually, Adrian, and both David. I saw your points go up there. I've been reluctant to go down the route of DAOs as well. That was what it's almost like naturally you go down that route and think, oh, we'll just use a DAO. And for me, whether you call an MPC a DAO because you're still trusting multiple parties and you got to have faith that they're, and is that just another version of a DAO? I don't know. I leave it up to you guys.
Yeah, DAOs are dangerous because you've got the problem that sometimes some parties feel that if they vote as a DAO, then they're liable for the action. And if something goes wrong, then kaboom. And so lots of people hence want to stand back, or lots of big companies want to stand back and let other people be the ones who vote. And then you don't have enough people vote. So the whole thing falls over. Yeah.
No, I think we all seem to have been burnt by DAOs.
Yeah. Yes.
Yeah.
Are there any other questions about the kernel technology? All right. Have you all been, oh golly, the chat's going wild. So for those people who are watching this on YouTube, you'll now know yet another reason for joining in live is you can read the chat as it's flying by. Okay. So let's give it another sec.
Yeah,
All right,
we've got.
sorry, go ahead.
No, just saying, obviously, regulation is coming about, and I think that is again another part of. I know it sounds weird, but we're all technical people, architects, and whatever. But ultimately, we hit that plateau, that ceiling where we have to look at the commercial and regulatory side of things as well, and that sort of hits. So again, very good. I'm really happy people are bringing that up.
Yeah. All right. There are those 3 extra slides that I asked you. Did you add them to the talk?
I did. I'm just going to put them up.
Yep. Thank you.
Let's do that again. Just share that. Okay.
Yeah. Okay. There are a whole stack of future talks coming up. And if we just go back to that previous slide.
Let's do that. So
yep. Whole stack of talk. All right. The merch store's there and down one. Yeah. We've got a whole stack of talks coming up. Next week, I'm going to talk about Ethereum L2 architectures, though your kernel technology is not included in that, unfortunately. But there are a lot of other tech that is. The week after that, I've promised someone that I would do a deep dive explanation on how seed phrases, derivation paths, private keys, accounts, wallets, how it's all interconnected and how it works and what the maths is behind that. In January, Serge and I have been doing a bit of Rust programming and creating Solidity dApps that use Solidity. And so we thought, look, we've learned it. Let's tell everyone about it. And Jen Yang's going to tell us in early Feb about Teller. And I also think that I've got a talk that is almost lined up for mid-February on data availability technologies and a overall ecosystem analysis of what's out there, what's good, what's bad, and where the technology is going. Yeah, haven't quite finalized that one. Next slide, please. Yep. So here are the socials. If you're here today, you can watch all this on YouTube. If you're looking at this on YouTube and wish you could ask some tricky questions, please join the meetup and then you can come along. Everyone can join the Slack workspace rather, and have discussions there. And sometimes there is example code. Certainly there will be for the Rust code. And that's all of the slides. So Tahir and ICE and team, thank you very much for that talk and, putting that or creating that technology. It seems really interesting. I'm really interested to see where it's going to go. And yeah, I look forward to, like hearing about you guys in the news. And then we'll all get a postcard from you to hear from the beach.
It was my pleasure. And no, thank you again. It's lovely to have, this talk to me, especially because there are people with so much knowledge here. And, please do reach out to me if you have any ideas or any things that you think that we can do to improve or technologies that I've missed. And that's the most important part. I only know as much as I can read in one day.
Yeah. All right. So thank you again. Have a great day, everyone, and talk to you all later. Bye-bye.
Bye-bye.
Bye.
Thanks.